Okay, I want to take a minute to look at Lab 2 because a number of you had some issues with Lab 2. And therefore, I wanted to make sure we got really off on the right track. So if we take some time today to go over it, I don't mind spending that time just to be sure that everyone's going in the right direction. Lab 2 is here. You're to create two classes. One called the Lab 2 class, or you could call it the unit test class, either one, is going to be the one that has the main method, the main function, and uses the other class. The other class is a student class. You generally name classes by the entity in the real world which they represent. In this case, we have a student number, residency code, credit hours, and name. All right. So those are attributes of a student. So therefore, it's best to call this class student. Some of you called it tuition, which isn't terrible, but student would be a more apt description. Keep in mind that in a real project, we would do more things with the student class than simply have a tuition calculating method. We would have methods for graduating, for adding a course, for dropping a course, all the things that students do, there would be functions for it. So think beyond the assignment at hand in how this would work into maybe a larger system. And therefore, this is representing students in our system. The student class represents one student. So each student is an object from the student class and so on. I'm going to create the student class. I'm not going to do all the Java coding though. I'm going to write comments where that is. And sometimes it's a very good idea to write comments for your code before you write the code, because in that way, you really understand what your code needs to do before you try to go ahead and write it. So let's look at the requirements again. It has these attributes, has these methods, get and set for all the attributes, and it has a method to calculate tuition. So let's go in to Visual Studio Code, if I can find it. And I'm going to create a new file. Make it bigger. So I'm going to say public class student. On your system, you might want to go ahead and install that, but I'm not going to in the interest of time. So public class student. And we put these brackets around to indicate everything between here and here is part of the student class. Now, all your code in Java is going to be in a class. And classes contain typically a couple of things. They contain attributes and they contain methods or functions. Now, one thing I want to make a point about is some of you sent in code that did not compile, which makes me wonder, did you try to run it and notice that it didn't compile, or did you not compile it, or what? Because if your code doesn't compile, you're not going to get any credit for the assignment. That's turning in something that doesn't even run. So therefore, if you are not understanding what you need to do to correct it, then you should contact me, that you should email me. So you should never turn in code that doesn't compile. All right. Again, I'd rather you spend some time, ask the questions, and get code that's working rather than struggle and just turn something in, even if it doesn't work at all, and even if it doesn't completely compile. I'm then going to have our attributes, and attributes for now are going to be private. And what are the four attributes that we have? Name, student number, residency code, and credit hours. So from an earlier class. Private string name. We're going to make our attributes private. We're using what's called, attribute hiding. We're not letting the outside world be able to access these attributes directly. They must instead use our get and set methods to change the values of these things. And that way we can put validation on it. We could set, for example, and we're not ready to do this right yet, but eventually we'll do things like we'll put validation on the residency code. So the user must, so the program that sets those residency codes can only enter in the valid residency codes, like maybe IC for in-county, OC for out-of-county, and OS for out-of-state. Now, a number of you made the student number a string. And it probably really doesn't matter with the student number because you don't perform mathematics on it. However, it does matter in a way because you don't want there to be any old characters to be put in the student number. So therefore, I'm going to declare it as an int. Notice the conventions I'm following. The class name is capitalized. All right. The class name represents a single one of these things. Therefore, student would be a better name than students. Where I refer to an object reference, class name is uppercase. So string is a reference to another class. Therefore, it's capitalized. Int, however, is a primitive. We'll talk more about primitives later on in the course. As the name implies, primitives are simpler than classes. So they are lowercase. For the names of the attributes, we use what's called camel case. And that is the first letter of the first word is lowercase. And each subsequent word is uppercase. So therefore, student number. I'm going to make a residency code. And here I might put some comments in to say, for example, that IC equals in county. OC equals out of county. OS equals out of state. You can put comments in this way, like 2 slashes, and this is good to explain to anyone reading your code just exactly what's going on. Then finally, I would have credit hours, which would be an int. So the first mistake I saw many people do is make everything strings. The best way to do it in this case would be to make ints for credit hours and student number to make strings for name and residency code. So that's what we're going to have. Notice we don't have an attribute for tuition. Why don't we have an attribute for tuition? Because we don't need to set the tuition directly. We're always going to calculate the tuition. In other words, if you give me this data, I can calculate the student's tuition based on some formula. So therefore, we're not going to store it as an attribute. Anytime we want the tuition to be calculated, we'll simply ask the function to recalculate the tuition. That way, if anything changed on the object, then the change will be reflected in the new tuition calculation. All right, I mentioned we're going to have gets and sets. These are methods and they will be public. So public set name, name of the attribute we put there. And my mistake, public void set name. And it's going to accept as an argument a string argument. And when we call this function, whatever argument we give it, we're going to set that student's name to be equal to this argument. So the set method is what's used to give an attribute a value. And we're going to typically, most of the time, definitely in this example, have a get and a set for both, for each attribute. Our get method is simply going to return the value. In lowercase first letter, uppercase each subsequent word. And it's going to return. Okay. So notice, this is string, so this is string, and this is string. This is name equals, this is return name, the name of the attribute. And we set that equal to whatever argument we give this function. We're going to have the same thing for the other attributes. Now, in the case of credit hours or student number, our function signature is going to be something like public void set credit hours. And it's going to say accept what is an argument, an int. And I'm not going to finish this function out, nor will I finish out this one. The gets accept no argument, but they return the type that's listed here. So let's see so far how we're doing. We have defined our attributes. We have gets and sets for all attributes. Well, I didn't code them all, but you would code them all if you're doing this as an assignment. Finally, we need a calculate tuition. This accepts no arguments. Why does it accept no arguments? Because the attributes of the student contain the information necessary to do the student calculation. So this is going to be public. It's going to return a double. The double is a decimal number. Calculate tuition. And it accepts no arguments. All right. Now, notice I call that calculate and not get. Get and set I reserve for attribute names. The calculate is something that is going to be take those values, those attributes, and do some math involved to come up with an answer. So if I look at this chart here, I notice the method for calculating tuition. And you could pull out your calculators to verify if what I'm saying is correct. But if you notice that tuition rate for Lorraine County residents is $164.03. That's for 1 credit hour. For 2, it's 328.06. Simply this times 2. 3 is 3 times that. So you might think, well, you just, for Lane County residents, you're always going to multiply the number of credit hours times this. That's not the case, though. Because if you notice, there's actually 3 sections of this chart, and each one is calculated a different way. For 1 to 12 credit hours, the tuition is equal to this value, the amount for 1 credit hour, times the number of credit hours. For 13 through 18, if you notice, you get 18 credit hours for the price of 13. So for 13 credit hours, the calculation is 13 times the tuition rate. And for 14, it's 13 times tuition rate. And 15 is 15 times tuition rate. And 16, it's 6. Oh, let me correct myself. For each of these, it's 13 times the tuition rate. It's not 14 times the tuition rate and 15 and 16. For all of these, it's the price of 13 credit hours, 13 through 18. And then when we start getting with 19 again, we start charging again. So 19 is the cost of 13 plus 1 additional credit. 20 is the price of 13 or 18 plus 2 additional credits, and so on. So that's a lot to absorb all at once, depending on your program experience and how comfortable you are with the language and all that. Therefore, I'm going to recommend that you do this a little teeny bit at a time. All right? So I'm going to write this to calculate 1 through 12 first, because that's simple. And I'm going to calculate, and if you look at out-of-county residents and out-of-state residents, it works the same way. So I'm going to set tuition, a variable inside the function. I'm going to declare it as a double. And I'm going to set it equal to 0. Just to give it a starting point. At the end of the function, I need to return the answer. And therefore, I'm going to return tuition. Now, if we wanted to break this down and do it just a tiny piece at a time, we could do something like this. Rate equals 164.03. Tuition equals rate times the attribute, which is credit hours, and return those credit hours and test it. Now, this isn't the whole function, obviously. This only works for 1 through 12 credit hours and in-county residents. But we have a start to it. And we can test this and we can make sure this works before we go on to add to the function. So one of my primary lessons of this lecture and of most lectures is that don't try to write the entire class, the entire function, whatever, all at once. Do it a little bit at a time. Get one little piece of it working, then add a piece, then add a piece, then add a piece. So I'm going to write what my test code would look like for this. So I'm going to create a new text file that I'm going to call either lab 2 or unit test. Now I'm going to hard code stuff in this. What do I mean by hard code? I'm going to use exact values. Now in completed applications, classes typically get their values from a window or an entry screen or something like that. Here we're going to hard code it, and we're going to make sure it works before we move on. So I'm going to go and I'm going to declare a student object. Say student S1 equals new student. Now at lab 2, at the point of lab 2, we haven't talked about constructors yet. So that comes in at lab 3. So I'm going to skip the constructors for now. Now I want to set all the properties using the set statements. So S1 dot set name, and you can put in parentheses the name, and make sure that it's a string, because we said it's going to be a string. We don't have the other functions now, but if we did, it would be set student number and so on. Finally, we're going to set the credit hours, which we also haven't written that function yet, but if we did, it would look like this. All right. So what this does is we take Mike, it's going to take that value Mike and put it in that new object that we created. Remember, an object represents one member of the class. So we have this generic student that represents all students. Now, in my test class, I'm dealing with this one particular student named Mike. I call all the get method or set methods rather to set the values. Now I want to calculate tuition. So we take the value that's passed, set the attribute equal to it. Now I want to do the calculation. So what I have to do is I have to say something like this. Double tuition equals S1 dot calculate tuition. And that accepts no arguments. Then I'm going to do something like this. System what gets me the value of that? The get method. Now we're going to do this for the other attributes too. Finally, we're going to come down to tuition. That's a variable, not a function, so we don't need the parentheses. And then what I usually like to do is do something like this. Print a blank line, or a dash line rather. What that will do then is when we have many, many test classes or test objects created, this will output and put a line in between them so we can easily read this. All right, take a look at this. For a second. Take a look at this. And let's think of the next thing that we want to add to it. Because right now we only work if the credit hours are 12 or less and the person is an in-county student. So let's think about this for a minute and think about how the next thing that you would change in it to start coming into getting the greater part of this chart going. Take a second to think about it and I'll be back. All right. What I think a good way to do it, we could do this a couple different ways, but I'm going to go and I'm going to try to get tuition working for the other residency codes. So in order to do that, we need an if statement. And I know there's other ways to do this. I'm going to do this the most straightforward way with 3 if statements. So I'm going to say if residency code dot equals, that's how you compare strings, IC, then the rate equals 164.03. Out of county, out of state, 189.21. And this one, 340.78. So our code still doesn't work for anything above 12 credit hours, or actually 13 credit hours, but it only works for the first part of the chart. Doesn't work for anything, but that's okay. We know that. And in fact, sometimes people will put in code like this, like a comment, and an explanation of what they still need to do. Check number of credit hours. So now we're going to go back to this, our test class. And we would have had to set our residency code to something. So let's say we set it the first time through to IC in county. All right. Now that only tests the one condition. We now have 3 rates in our student class. So guess what? We need 3 test cases. So we're going to clone this. Because we have to test, if possible, all the possibilities. If not, as many of them as we can. So what would I do? I'd go in and I'd change this to 2. This to 2. This to 2. And then the same thing for the other one, except we could change it to OS for out of state. Well, we have 3 conditions. Why 3 conditions? Because there's 3 possibilities of how our code could work. It could either work this way, or this way. Now, finally, we have to take care of the credit hour issue. So there is going to be a different set of rules. So if credit hours is less than 12, then tuition equals tuition times rate. If credit hours is greater than or equal to 13, and credit hours are less than or equal to 18, then credit hours, this says tuition, it should say tuition, my mistake. It should say it equals credit hours times rate. And in this case, we can put 13 in because for 13 through 18 credit hours, they get charged for 13 credit hours. Finally, and I'll leave this up to your own self to try to figure out. If credit hours are greater than or equal to 19, then we have a different formula. And I'll leave that to you to try to figure out what that is. By all means, ask if you can't figure it out. Now, as far as testing goes, well, we have 3 possibilities for the residency code, 3 possibilities for the credit hours. That would mean at the very least would need 9 test cases. An in-county student who took less than 12, an in-county student that took between 13 and 18, and an in-county student that took more than 19 credit hours, more than 18 credit hours. So that's 3, and we need 3 for the other 2 residency codes. Really though, we should probably test maybe 12. Test the difference between 12 and 14, let's say, then test the difference between 18 and 19. That would put 2 in the middle category and 1 in each of the other 2 categories. So that would be 4 for each residency code, or a total of 12. Take the time to correct your previous assignments if you did not do it correctly, if you got points off. I think this is the best deal at Lorain Community College, that in my classes, until it gets to the very end, you can rework assignments and correct and get any points that you have not gotten. And if you don't correct them, they're going to just keep coming off on the next assignment and the next assignment and the next assignment. So go and correct assignment 2, assignment 3, and use this sort of as a model of how to do it. Right? This is not the lecture I plan to give today. I plan to talk about inheritance. We'll save inheritance for next week, and I will probably adjust the due date of the first assignment dealing with inheritance, just to compensate for the fact that we spent this lecture. But looking at the issues that students had with this, I think is well worth it for us to take the time to go over it. All right, that's all I had for today. We will see you in lab or next week.